Hello, my name is Thorsten Schech, I'm Head of Marketing. Today we're going to talk about optical resolution of thermal images. And at first we need to define some terms. For example, field of view. Field of view, the short code is FOV, and this is the angle at which the device can detect the target object. It can be expressed as horizontal field of view, HFOV, or vertical field of view, VFOV, or even sometimes also as diagonal field of view, DFOV. The next term is the so-called instantaneous field of view. The instantaneous field of view, IFOV, is the smallest target size detectable by an imaging system. It represents basically 1 pixel of the sensor array, and therefore it is the smallest resolvable object size. And then we have also in our literature, in our data sheets, on our website you find MFOV. This stands for measurement field of view. The measurement field of view defines the smallest target size required to obtain accurate temperature readings. So very important, instantaneous field of view is the single pixel, the smallest resolvable object size, and if it comes to temperature measurement, to accurate temperature measurement, then we need measurement field of view, a different definition. And usually this measurement field of view is defined for an object size of 3 × 3, sometimes 4 × 4 pixels, where we have 90% of the target's energy obtained. So it depends on the optics if we need 3 × 3 or 4 × 4, sometimes even only 2 × 2 pixel. And of course we have different optics in our imagers with different field of views. Sometimes, as on our PI series, we can directly exchange the optics. Sometimes the optics is built in the camera, fixed, but different field of views are available. You see here an example. If you look on the data sheet of our PI 640, for example, then you see we have different field of views, starting with the tele lens, 15-degree field of view, standard lens, 33-degree, up to wide-angle lenses with 90-degree field of view. And in this graph, you see very good what we explained one slide before. So you see our field of view, that means the angle is giving the field of view. And of course, if you increase the distance, your field of view gets larger and larger. And then you have at a certain distance a certain horizontal field of view in meter or millimeter, a vertical field of view, and also a pixel size on the object size, on the object side, which we defined as instantaneous field of view. And if you want to see which optics for a specific imager has which data at a certain measurement distance, then you can look on our brochures, for example, where there we have those kind of optic tables. So you see here you have different measurement distances, and you see all the data, field of view, pixel size, angle, minimum measurement distance, and so on. And you can check this for different optics. Of course, we have also a way to do this more comfortable. And if you look on our website, for example, you find an optics calculator where you can easily enter the desired camera and select a specific lens, enter a certain distance, and then you get all those data at a glance. So that means check our website, there you find this optics calculator. And even more comfortable for mobile devices, we have this also as app for Android and also for iOS. Yeah, some other terms we need to talk about. One is optical resolution. Optical resolution is related basically to the number of pixels, and it indicates the ability to resolve an object with sufficient accuracy. And then we have the F number. The F number is defined as the ratio of the focal length to the effective aperture diameter, or entrance pupil. easy to say, also you can say the F number defines the opening of your optics. That means if you have a high F number, it means the aperture of your optics is very small and you get less energy through your optical system to the detector. The F number therefore is also influencing different other parameters on the imager, like the depth of field and also the thermal resolution. A low F number also can lead to image blurring. Here we see some different camera resolutions. On the left image we see an 80 by 80 pixel imager with a 34 micrometer pitch detector. What does it mean? The pitch means this is the size of a single pixel on the detector array. 80 by 80 pixel, so you see the image looks not very sharp. In the center we see the same object, the same scenery, and basically the same field of view here in this case, but with a higher resolution of the camera. Here we have 384 by 288 pixel and a smaller pixel pitch, that means a smaller size of a single pixel on the detector, 17 micrometer. And on the right side we see a so-called VGA resolution, 640 by 480 pixel with a 12 micrometer pitch detector. So we can also say a low F number is enabling competitive imaging even with 12 micrometer pixel size. Why is MFOV so important? We say for accurate temperature measurement, the target size must be larger than the instantaneous field of view due to the diffraction limit of our optics. And a serious value for an exact temperature measurement is 90% energy. So that means in our measurement field of view, which what we learned today has a size of 3 times 3, sometimes 4 times 4 pixel, we need at least 90% energy. So again, in this graph you see a part of our focal plane array, which is the matrix detector in our infrared imaging system. And it's this detector element. We have different pixels, and one pixel size is here the instantaneous field of view, and then we have 3 times 3 pixel, which is our measurement field of view on the object surface. And this 90% energy is something we are testing for each single imager of our PI series in our running production. So you see here a test bench where we put in front of a radiation source a special grid with square holes. And those square holes are representing 3 times 3, 2 times 2 and 1 pixel MFOV for a certain imager. Yeah, we made this test here as an example for our PI 640i with a 33-degree lens. This is an f/0.8 optics, so a quite low F number. That means we have a high opening of the optics. And we see, if we look through this grid at 1 pixel, we get only 59% of energy. So this is not enough for an exact temperature measurement. But at 3 times 3 pixel, we get in the image center 94% and even in the image corner 90%. And the goal for us is to achieve more than 90 or equal than 90% energy in all parts of the image, in the center and also in the image corners. Yeah, we made here also a comparison with another VGA imager not produced by Optris. So it's a fair competition, I would say. It's also VGA 640 by 480 pixel. The field of view is similar. We have here 42-degree optics. And you see the F number is a bit higher. What does it mean? We have the optics is more closed. The aperture of the optics is more closed and we get less energy. And we see here at 1 pixel we get only 39%. But even at 3 times 3 pixel, our criteria is not fulfilled to have 90% energy. So we have here only 87%, or in the image corners, even only less, 83% of energy. Yeah, again, this graph shows also the MFOV size at the sensor and the encircled energy, and you see 90% we are reaching here with 3x3 pixel. And with other VGA imagers, here's another example. For example, we reach 90% energy only at 7x7 pixels, depending on the optics. So what does it mean? I mean, basically people tend to compare only number of pixels. That means I have here an imager A, 640 times 480 pixel, and I have an imager B with the same resolution, so must be the same, but it isn't the case. If it comes to exact temperature measurement, then of course this MFOV plays an important role. That means if you just need 3x3 pixel, you can resolve or you can measure the temperature of smaller objects than with the other imager where you need 7x7 pixel. That's clear. Here's a practical example. We are looking here at a hot wire with different optical resolutions. So a very simple measurement task, you can say. It's just a hot wire in a standard environment. And we are looking on the left image with a 640 times 480 resolution VGA imager, and we measure 70 degrees Celsius as a wire temperature. We are looking on the same object, the same wire, under the same conditions with an imager which has just 80 by 80 pixel. And you see we are measuring totally wrong, just 35.6 degree. So we make a complete wrong measurement, and the reason is that our MFOV is not fitting to the object size, to the diameter of the wire. So this is very important. Therefore, please don't look only on the number of pixels. Have also a look on our optics tables and compare it to the size of your real objects which you want to measure. As a summary, we can say a camera with a high optical resolution can resolve finer details. This is critical when examining small or distant objects. The field of view selection is closely linked to the camera's optical resolution, and it refers to its ability to distinguish small details. The trade-off between the field of view and the optical resolution is a key consideration in thermography, because this is affecting the quality, finally, of the thermal imaging results. Yeah, if you would like to have more information, please visit our website and also follow us on our social media channels.